So to calculate central closeness centrality, closeness centrality. So let's use this graph. So for example, if you want to calculate the central closeness centrality of weak leaf, to calculate the closeness centrality of weak leaf, we will look all the vertices. So first we have this one, this one, this one. We have 3 here from weak leaf. Then there is one going to Lynette, there's one going to Derek, and there's one going to James. So there, from Lynette to weak is 1. From Derek to Wycliffe is another 1. Then from James to Wycliffe is another 1. So there, so because there are 3, we'll write 1 times 3. Haya, plus sasa ukikuja kwa Lynette hakuna node yenye imeconnect kwa Lynette. Ukikuja kwa Derek hakuna yenye imeconnect. Lakini ukikuja kwa James kuna zingine 2 pia. Na ukitoka kwa Wiki to James ni 1, from James to Celestine, from James to Celestine is another, now is 2, so is 1 2. Haya, so we have 2, 1 and 2. So from Wycliffe to James 1, from James to Celestine is 2. Haya, that's the first 2. Haya, from Wycliffe to James is 1, from James to Geoffrey is another 2. So it's like 2 times 2. 2 times, it's like 2 times 2. 2 times 2. Haya, plus. So from James kuna ingine imekuwa connected to Celestine. Then from Celestine there is another one connected to Denise. So from Wycliffe to James 1, from James to Celestine 2, from Celestine to Dennis 3. Now we have 3 there. Haya, so there's now from James to Geoffrey yenye tumecount kama 2. Then from Geoffrey there's another one to Charles. So from Wycliffe 1 to James, from James to Geoffrey another is 2, from Geoffrey to Charles is 3. So we have 2 3s. So we have the first one from Wycliffe to James to Celestine to Denise, that's 3. Then from Wycliffe to James to Geoffrey to Charles, that's another 3. So we have 2 3, so is 2 times 3. Haya, plus ukikuja kwa Dennis inaishia hapo. Kwa Charles, ukikuja kwa Dennis inaishia hapo. Kwa Charles pia inaishia hapo, hakuna other node. Ukikuja kwa Geoffrey kuna ingine inaenda tu Geoffrey to Collins, yeah. Geoffrey to Collins. Actually, from Geoffrey to Collins is another 3, because from Geoffrey to Charles is another 3. Geoffrey to Collins is another 3. So ni 3 times 3, not 2. So ni 3 times 3, not 2 the way we had written. Haya, then from Collins, there's another note from Collins to George. That's now the 4th one. So plus 4, yeah. Plus 4, yeah. So there is Lynette to Wycliffe 1, Derek to Wycliffe 1, James to Wycliffe 1. That's why we have written 1 times. That's why we have written 1 times 3. Haya, we are going to the second node. Lynette doesn't have another node. Derek doesn't have another node. But if we come to James is also connected to Celestine and again connected to Geoffrey. So let's have for Celestine. So from Wycliffe, Wycliffe to James is 1. From James to Celestine it's another 1. If you combine 1 plus 1 is 2. So it's like 1 2. We are done with Celestine. Now to Geoffrey. So to Geoffrey is the same. From Wycliffe to James 1, from James to Geoffrey is another 1. That's 2. So from Wycliffe to from Wycliffe to Geoffrey is 1 2. So Geoffrey is 2. So we have Celestine and Geoffrey 2 2. That is 2 times 2. Higher. We are done with Celestine and Geoffrey. So we are looking at the nodes that are connected to Celestine again and Geoffrey again. So from Celestine, Celestine is also connected to Denise. Yeah, Denise. That's now 3. So from Wycliffe, James 1 to Celestine 2 to Denise 3. Yeah, that's the first 3. Then again from Geoffrey is also connected to Charles, and again Geoffrey is connected to Collins. So from Wycliffe to Charles is 1, then 2, then 3. That's the second 3. Then there is also Geoffrey to Collins. So from Wycliffe to Collins another 3. 1, 2, 3. Yeah. So we have 3 3s. So that's why we have written here plus 3 times 3. Plus. If you look Charles, Charles is now not connected. Dennis from Celestine is also not connected. But if you come to Collins, it's connected again to George. So from Wycliffe to George is 4. From Wycliffe to George, you will count 4 because 1, 2, 3, 4. So that's why we have written here plus 4. So from George is not connected, which means there is no any connection again. Yeah, George is the last one. Then is the last one here. Then Charles the last one. So there is no any connection again. So you will come here. Closeness centrality is equal to all nodes minus 1 over all the vertices connected. So you look the formula for this one. This one is there to show you. So that one is 14 minus 1 over. So you will add all these. So this one times this one. This is 3 plus 6. 3 plus 6 is 9. Plus 9. 3 times 3 is 9. So 9 plus 9, 18. Plus 4, 22. That's 22. So it's 13 divided by 22. Then you find the answer. Yeah. So you just follow this one to calculate you just use this one to calculate the others. So you will find that for example, like wiki is connected to 3. Then if you come here from wiki is connected to 3 here. So wiki to James is connected. Then James is connected again to another 2. So we'll calculate for each. Then if you come to Celestine is connected to Denise, only 1 connection. But if you come to Geoffrey, 2 connection, 1, then 2. So you calculate both 2. Then from Collins to George, higher. Another example, so from Jane to Livingstone, there's 1 connection. So you will because James has only Livingstone as a connection. So there you can calculate Jane is 14 minus 1. That's Jane. So Jane is okay. This one was for Wycliffe. Jane is only having 1 connection. So 14 minus 1 over 1. That's 13. Then you are done with Jane. The same will go to Livingstone, who has only 1 connection with Jane. Then for example, if you come to Geoffrey, he has 2 connection. Charles, then actually not 2, 3. Yes, Charles, yes, James, Yes, Collins. This one is like 1 times 3 higher. Then Collins again to George, it ends there. Then from James to James is also connected to another 2. Celestine, Wycliffe. You will calculate for both Celestine and Wycliffe. Then Wycliffe is also connected to another 2. Derek, Lynette. Celestine is also connected to another one, Dennis. So you will calculate until the end of the node. Yeah, I hope I'm clear for closeness centrality. So degree, so that's what closeness centrality. Yeah, it is here. So let's go to degree centrality. So for degree centrality, for example, let's calculate for degree centrality for Wycliffe. For Wycliffe. So degree centrality for Wycliffe will be degree centrality for Wycliffe. Wycliffe is connected to 3 nodes. 1, 2, 3. 1, 2, 3. Higher. So to calculate degree centrality there, let me show you. For Wycliffe, degree centrality will be now. Degree centrality for Wycliffe will be now. Connected. But it's over not minus 1. That will be, so this one is easy. You will only come to count Wycliffe. For example, Wycliffe is 1, 2, 3. So there you will only come and write 3 over 14 minus 1. You saw this one is easy. Then for example, if you come to Livingstone, only 1. So there you will only write for Livingstone is 1 over 14 minus 1. Another one is for Geoffrey. Geoffrey is 1, 2, 3. So it's 3 over 14 minus 1. So degree centrality is not this. You don't follow the nodes until the end. You only count for the first 3 nodes. For example, 1, 2, 3. So you don't follow like James to Celestine again. That one is for closeness centrality. So I hope that there I'm clear. If you use the same to calculate George is only connected. The first connection is 1, so you will only 1 over 14 minus 1. Another one is Collins. Collins is 1, then another 1. That's 2. 1 plus 1 is 2. You don't follow this path. Then you go again. That one for closeness. For degree you can count 1. The first one 1, 1. That one is 2. 2 over 14. 2 over 14 minus 1. Yeah. So I hope there I'm clear. So for betweenness centrality is when I'm calculating. If I'm done, I'll get you to know.